Hi, my name is Sudarshan. Welcome to my channel EasyML. In this video, we will see how we can deploy the k-means clustering algorithm to build cluster models. What is k-means clustering? By definition, the k-means clustering algorithm aims to partition n observations into k clusters. Note that here the value of k implies the number of clusters we want on a particular dataset. And the value of k can be determined by the analyst. So the k can be 1, 2, 3, or can even go as high as 50. But is there a way to select the optimum k value, or in other words, choose the optimum number of clusters? The answer to that question is yes. We have a plot called the within group sum of squares plot, or in other words, the Wss plot. This plot will help determine the optimum number of clusters. In this Wss plot, on the x-axis, we have the number of clusters. In other words, it just means the multiple k values, since k is the number of clusters. And on the y-axis, we have the Wss value. Now, what does the Wss value help measure? Well, the Wss value helps measure the amount of variation within a particular cluster. Recall from our last video that we know that one of the main objectives of cluster analysis is to reduce within cluster variation, as highlighted in red here. Since the Wss helps measure this within cluster variation, we can conclude that if the Wss value is high, it implies that the variation within clusters is also high. And if the Wss value is low, it means that the variation within a particular cluster is extremely low. Now, here on the left, I have 6 observations. Let us try and derive the optimum number of clusters for these observations by looking at the Wss plot. Now, let us take an extreme scenario where what is the minimum k value that we can take in this case? As in, what is the minimum number of clusters that we can have? It is obvious that the minimum number of clusters or groups is when k is equal to 1. That is, when we group all these 6 observations into one big cluster. Now, empirically speaking, we can see that some of these observations are far away from each other. Hence, the variation within this particular cluster is likely to be extremely huge. Now, let us take another extreme scenario. Given that I have 6 observations here, what is the maximum number of clusters or groups that I can have? Here, we can see that we can have a maximum of 6, as in, I will deem every observation to be a cluster of its own. Here, although the variation within is going to be the least, it is pretty infeasible. As if you recall, the 2 objectives of cluster analysis is to reduce within cluster variation and increase between cluster variation. Here, by ensuring that every observation is a cluster of its own, I have taken care of the first objective, that is reducing within cluster variation, but I have not taken care of the second objective, that is increasing between cluster variation. For instance, let us take these 3 points here, highlighted in red. They seem to be so close to each other, right? Hence, instead of these 3 points being a cluster of their own, they should be grouped together, don't you think? Now, given that we have seen both these extreme scenarios, when it comes to the selection of k values, we can safely say that the optimum k value naturally lies somewhere in between. When we see the Wss plot, we need to look out for a kink in the shape of an elbow. This kink is where the optimum number of clusters lie. Here, we can see that the optimum number of clusters is when k is equal to 2. If you remember the fairy tale Goldilocks and the 3 bears, well, we must choose the optimum number of clusters like Goldilocks did. K is equal to 6 is too much, k is equal to 1 is too little, but k is equal to 2 is just right. In the next video, we will explore how the k-means clustering algorithm assigns observations into a particular cluster. Stay tuned. Thank you.